Hi everyone, this is AGS Knowledge and Learning channel. In this video, we will see about classifications of systems under the subject signals and systems, in which I will explain classification of system definition, 2 marks, MCQs, multiple choice questions with relevant answers, which belong to unit 1. So these are the 2 marks we are going to discuss. One by one we will discuss in detail. So first of all, what is a system? System is one which transforms one form of energy to another form. Okay. So input will be denoted by x of t and output is denoted by y of t, in which input is also called a source or excitation, and output is said to be response. You can draw the diagram also. So classifications of system. So system can be classified as the following: CT and DT, that is continuous time and discrete time system; static and dynamic; causal and non-causal; linear and non-linear; time variant and time invariant; stable and unstable systems. So what do you mean by continuous time system? A continuous time system is one which transforms a continuous time input signal into a continuous time output signal. X of t will be converted to y of t. So example, y of t equal to x of 2t, etc. You can write. Discrete time system. A discrete time system is one which transforms discrete input signal into discrete output signal, that is x of n will be converted to y of n. So those systems are called discrete time systems. Example, y of n equal to x of n plus 2. Like that expressions you can write as examples. Static system. So static system is otherwise called as memory-less system. A system is said to be static if its present output at any instant depends only on the present input. Okay, present output, present input, and not on the past or future values of input. So those systems are called as memory-less system. Example, x of t, y of t equal to x of t, 2 into x square of t, y of n equal to x of n, 5x square of n. CT as well as DT systems can be given as examples. Dynamic system. A system is said to be dynamic if the present output depends on the past or future values of input. Those systems are called memory systems. So y of t equal to x of t minus 3, y of n is equal to x of 2n. So those systems can be written as examples. So the difference between static and dynamic system is that static system is called memory-less system and dynamic system is called memory system, in which in static system the present output depends on present input. Here in dynamic system the present output depends on past or future values of the input. These are the differences between static and dynamic systems. So what about causal system? A system is said to be causal if its present output at an instant t, or it may be continuous or discrete, depends on present and past values of input and not on the future values of input. It depends on present and past and not on the future values of input. It is also called as non-anticipative system. Example, y of t equal to x of t minus 2. So t minus 2 is past and 2 into x of t is present. So y of t equal to tx of t. Y of n equal to x of n minus 3. N minus 3 is a past input. X of n minus 1 is again a past input, plus x of n will be a present input. Okay. So the other name of causal system is non-anticipative system. So non-causal, a system is said to be non-causal if the present output depends on the present, past as well as future values of the input. Or you can say a non-causal system is one in which its present output depends on the future values of the input. It is otherwise called as anticipative system. So you can write y of t equal to x of 2 t plus 2. So t plus 2 is a future input, 3t it is also a future input, and n plus 8 is again a future input. So the difference between causal and non-causal system is causal system is called as non-anticipative system, in which non-causal systems are called anticipative system. Causal system, you can write the present output of the system depends on the present and past values of the input, and in non-causal you can write the present output depends on the future values of the input, or in the other way you can write it depends on the present, past as well as future values of the input. You can write some expressions as example also. So these 3 points you can write as differences. Linear system. A system is said to be linear. You can write simply, you can write a system is said to be linear if it obeys superposition and homogeneity principle. But here I have explained the superposition and homogeneity principle. Okay. So a system is said to be linear if an input x1 of t produces output y1 of t, and an input x2 of t produces an output y2 of t. So this x1 of t and x2 of t are said to be an arbitrary input. What do you mean by arbitrary? Random. So whatever may be the input, arbitrary input x1 of t, arbitrary input x2 of t produces output y1 of t and y2 of t. Then weighted sum of inputs a into x1 of t plus b into x2 of t. So what is a and b? A and b are constants. So those will produce output a into y1 of t plus b into y2 of t, which is the sum of the weighted outputs. So in the simple way you can write an expression for a CT system to be linear. T, what does T represent? Total. T represents total. Here also T represents total. This is for a CT system. So total of sum of a x1 of t plus b x2 of t is equal to a is a constant we have taken outside, a t of x1 of t plus b t of x2 of t. Similarly, for a dt system to be linear, so you replace t by n. So small letter t by n. So here t as usual it indicates the total or sum of a x1 of n plus b x2 of n is equal to a t x1 of n plus b t x2 of n. So let me explain it again. A system which obeys the principle of superposition and principle of homogeneity is called linear system. So combining them I have written here, a system is said to be linear. We can say that a system in which if an arbitrary input x1 of t produces an output y1 of t, and an input x2 of t produces output y2 of t, then the weighted sum of inputs a x1 of t plus b x2 of t, in which a and b are constants, produce output a y1 of t plus b y2 of t, which is the weighted sum of outputs. So for non-linear you have to write the same definition, but instead of produce output you should write does not produce output a y1 of t plus b y2 of t, or in the other way you can write it does not obeys the principle of superposition and homogeneity. And then you have to separately explain what is homogeneity. Homogeneity is a property which means a system which produces an output y of t for an input x of t must produce output a y of t for an input a x of t. This is homogeneity. So what about superposition property? So superposition property means a system which produces an output y1 of t for an input x1 of t and output y2 of t for input x2 of t must produce y1 of t plus y2 of t for an input x1 of t plus x2 of t. So in this way also you can write the answer, but the clear difference is for linear system it produces output, for non-linear system it does not produce output. Okay, so expression also you can write here not equal to, and in the that's definition you can write equal to. So those are the differences you can write. Okay, next, time invariant system. So what do you mean by time invariant system? It is otherwise called as shift invariant system. Okay, a time invariant system is one whose input or output characteristics do not change with respect to time. So what is that it do not change with respect to time? That is a system for which a time shift in the input results in the corresponding time shift in the output. That is, input, if there is a change, there will be a corresponding change in the output also. So that system is called time invariant. Okay, so it is otherwise called as shift invariant system. So time variant system is one whose input output characteristics change with respect to time. So that is a system for which a time shift in the input does not result in a corresponding time shift in the output. So that is time variant system. Produces change means there should be a change, right? It results in a change. Okay, here. So if there is a time shift in the input, there should be a time shift in the output. If there is no time shift in the output, so that system is said to be time variant system. It is otherwise called as shift variant system. If a continuous time system is described by a differential equation, so how the time invariance can be found? They can be found by observing the coefficients of the differential equation. For example, what I am saying is d square x or y of t by dt square, like that an expression will be given, right? They will be asking whether this system is a time invariant or a time variant system. So in those cases, if the coefficients of the differential equations are constants, then the system is time invariant. If the coefficients are functions of time, then the system is time variant. For example, d square y of t by dt square plus 4 dy of t by dt is equal to x of t. So here the coefficients are, first coefficient is 1, second coefficient 4. Here the coefficient of x of t is 1. So here the coefficients are constant. So the given differential equation which belong to a CT system is time invariant. Another case, here 4t. Another case. Okay, so the first coefficient is 1, second coefficient is 4t, and the third coefficient is x of t. Here one of the coefficient is t, right? So one of the coefficient depends on the function of time. So here the system is time variant. Okay, so these differences you can write as example. So the first difference is input output characteristics do not change with respect to time for time invariant system. Second point, input results in the corresponding time shift in the output. Third point, you can write shift invariant system. Fourth point, you can write example. In time variant system, you can write input and output characteristics change with respect to time. And second point, you can write input does not result in the corresponding time shift in the output. And third point, you can write it is otherwise called as shift variant system. And fourth point, you can write example. Stable and unstable system. A system is said to be stable if and only if every bounded input produces a bounded output. It is otherwise called as BIBO stable. B for bounded, I for input, B for bounded, O for output. So this is BIBO stable. So what is the necessary condition for a system to be BIBO stable? So this is the condition. So for a CT system, the condition is integral minus infinity to infinity modulus of x of h of t dt should be, if we calculate it, the value should be less than infinity. And summation, this is for a dt system, summation n equal to minus infinity to infinity modulus h of n should be less than infinity. So what is h of t? H of t is the impulse response of the CT system, and h of n is the impulse response of the DT system. So a system is said to be unstable if and only if every bounded input does not produce bounded output, or otherwise you can write bounded input produces an unbounded output. Okay. So what differences we can write? First difference is a system is said to be stable. In stable systems you can write every bounded input produces bounded output. Then you can write this sufficient conditions. If the condition is satisfied, the system is said to be BIBO stable. Then you can write example. And in unstable system you can write a system is said to be unstable if every bounded input produces unbounded output. And then you can write the definition. If this condition is not satisfied, the system is said to be unstable. Then you can write the example also. So MCQs dash, we have studied different types of systems and definition, right? So from that I have taken the MCQs. So try answering it. Okay. So dash is one which transforms one form of the signal to another form. The answer is system. A system whose output depends on the present value of the input. We can say two answers: static system as well as causal system. Present value of the output depends only on the present value of the input. A system whose output depends on present and past values of the input, it is causal system. A system whose output depends on future values of the input, we can say two answers: dynamic system and non-causal system. So both B and D. A system whose output depends on present value of the input. So present value of the input is, again this question is repeated I think, static and causal system. A system which is called memory-less system. So memory-less system is static, and a memory system is said to be dynamic, and non-anticipative system is causal system. System which is also called as non-anticipative system, causal. What about anticipative system? It is non-causal system. Next, a system which is called shift variant. So shift variant system is time variant system. So shift invariant system is called time invariant system. So for a continuous system to be stable, its impulse response must be impulse response, that is h of t. So the condition is integral minus infinity to infinity modulus h of t dt should be less than infinity. That is, it should be absolutely integrable. So in the similar way, for a discrete time system to be stable, the impulse response summation n is equal to minus, try this formula also, modulus of h of n should be less than infinity. So this is absolutely summable. Its impulse response h of n must be absolutely summable. For time invariant system, its dash do not change with respect to time. Its input characteristics, output characteristics, or it is bounded. No, input as well as output characteristics do not change with respect to time. So these are the MCQs I have taken. So since the topic is about classifications of system, definition I have explained. So in that 2 marks I have taken. So from that also MCQs with the relevant answers I have given. So go through the video. You can write differences between different systems, CTDT, static, dynamic, other names of the system you can write as differences. So I have given other videos. For the following videos you can click the playlist of this channel. So try supporting this channel. So thanks for watching the video. Thank you.